There we go. Hi, welcome back.
Morning.
Good morning. My computer decided, I don't know what it was doing. It didn't want to record. So here's what we've been working on the past few days. We've been graphing the transformations of absolute value functions. And we looked at it in this very graphical way. And so I'd like us to warm up by completing the notes and finishing out this one example. So this is where I'm going to start. This was yesterday's notes, and we're just going to finish it out. As I'm looking at this, I notice that this graph is already, this function's already graphed for me. It's an absolute value function, and it looks like they shifted it to the left 4 units. And so if I look, I see my standard absolute value function, but it's shoved over to the left 4 units. So this is the function I'm going to start with, and I'm going to do what this thing is asking me to do. Looking into it, I'm multiplying here inside by some value. It's a negative. And I'm subtracting some value out here. Okay, I'm going to look at this multiplication here first. According to my notes, when I'm multiplying something in the input and it's a negative, it's a reflect on the y. So this is reflect y-axis. Okay, and when I have some sort of addition or subtraction happening, hanging out outside, it's one of these. It's a vertical translation, up or down. In this case, it is
Down.
good. So this is a shift down 1 unit. All right, so I'm going to apply both of those transformations to the graph that I've been provided. All right. This is a reflect across the y-axis. This is my y-axis. And so I'm going to count how far away each point is from the y-axis. And then I'm going to count that distance from the y-axis again, but on the other side of it. So this point is 1, 2, 3, 4 away. So from the y-axis, 1, 2, 3, 4 away. This point is 1, 2, 3, 4, 5 away. So I'm going to count 1, 2, 3, 4, 5 away. This point is 1, 2, 3 away, so 1, 2, 3 away from the y-axis. And I could keep going, but this is enough points for me to use my straight edge and draw a line. So I'm going to connect these 2 points with a straight line. And I'm going to turn my paper, and I'm going to graph these 2 points with a straight line. All right, and so my graph looks something like this. I'm not done though, because I need to do the shift down 1, so I'm going to grab the pink graph because that's the one that I reflected, and all of these points that I found, I'm just going to shift them down 1. I could definitely do this for as many points as I wanted or needed, but once I get an idea of what the graph is going to look like, I can bust out my straight edge and graph it. Can I have one question about this part?
So you just need to graph at least 3 points?
I need to graph as many points as I need. If it's a straight line, I only need 2 points per straight line because I've got 2 of these going out this way. I needed 3. The vertex and then 1 on either ray.
Oh, okay.
Can I skip the pink step? Yes, if you can think it through in your head. I recommend not skipping the pink step until you are feeling more comfortable with these. But the moment you're feeling more comfortable, like, go ahead and skip whatever you need. All right, let's run vertex x of symmetry, x-intercept, and y-intercept of the green graph. Where's the vertex? 4, -1. The vertex is located at the point 4, -1. The axis of symmetry is always some sort of vertical line going through the vertex. All vertical lines have an equation of x equals. And so the equation for the axis of symmetry is? Good. X equals 4. The x coordinate of your vertex. The x-intercept is where this graph touches the x-axis. I have 1 touch here and 1 touch here. Can I please have those 2 points?
3, 0, and 5, 0.
Good. Thank you very much. When it touches in two locations, you must list out both. I'm sorry.
No. Yes. Okay. Yes.
Okay.
The 5 or the 6 in the end looks like a 5 now.
It does look like a 5. It is a 6 because if I start from here and count by ones, 1, 2, 3, 4, 5, 6. Okay. Thank you. The y-intercept is wherever it touches the y-axis. I have a touch right here. What is the coordinates? 0, 3. Good. Questions on this thing? Feels really good and really comfortable, and you're going, yes, I nailed my homework, and I'm just going to finish like the last one or two and turn it in, yeah? Good. Let's turn out the page. I'm going to be doing a lot of turning back and forth, so I'm going to actually bust out a note from another class just so that I can look at this portion. But you may have to flip back and forth. So what we've just done, namely these things, can be done to any function in the entire world. We did it with lines. We're doing it with absolute value. When we get to quadratics, parabolas, we're going to do it with them. We're going to do it with cubic functions, whatever those things are. Polynomial functions, whatever those things are. Exponentials and logarithmic and trigonometric. And suddenly it sounds like I'm just making up words to confuse you. I promise I'm not. Someone else made up the words. I'm just using them. I'll show you what all those graphs look like, the parent function, and we'll be doing this to those. And the things that these 4 transformations control, the vertical stretch or compression, the horizontal stretch or compression, the vertical translation, and the horizontal translation and the vertical translation, all of those remain the same. They're located in the same place, and they move it in the same ways, regardless of what function I hand you. Okay? I have 4 examples using absolute value. May I please have which example you would like me to start with? Top left, top right, bottom.
Bottom left.
Bottom left? Bottom left with the fraction. Oh my God, fractions are hard. All right, let's look at what we've got. This is my function f of x. It gives me some rule. This is the transformation they want us to apply. Here's my function, and this is part of the transformation that's being applied. What is being applied? A what? The half. What's happening with the 1/2? Is it a multiplication thing or an addition thing? It's a multiplication thing because I don't see a symbol between the 1/2 and the function of x. It's happening outside of the parentheses, so it's one of these. See how it looks the same? If I were to place the a with the 1/2, it would look identical. Good. So the next question we have to ask ourselves, greater than 1, between 1 and 0 and 1, or negative. Between 0 and 1, this is some sort of vertical compress. And so I'm going to talk about how it is changed as a vertical compression. To talk about how far we have a compression, we can talk about its compression factor. Factor meaning the thing you multiply by. What am I multiplying by? The half. And so my vertical compression factor is 1/2. Okay, now that we know how it changed, let's actually monkey with how we write the equation. Yeah, we're going to monkey with it. All right, this is the entire function. This is the entire function. So my new function, I'm going to name him George. Hi, George. Nice to meet you. Is going to be 1/2 times whatever the f of x function said it was. In this case, the f of x function is the absolute value of x plus 2. And I have 2 grouping symbols, and suddenly it looks weird. Do I need the parentheses? No, because I don't have anything else that I multiply, that I'm like adding inside of the parentheses. Ignore the think of the absolute value as just like a box, right? We can't get into it yet. We're looking inside the parentheses. I only have one thing on absolute value. I have a one thing inside the parentheses. I don't have two things being added together. It's just one. So I'm going to rewrite this function this way. And then the next question is, do I distribute? Exactly. I'd have to get the absolute value of the inside thing first, and then multiply it by 1/2. Which means absolute value is a stronger grouping symbol than the parentheses because it does not allow you to distribute into it the way parentheses do. Which means there's nothing more I can do right now, and I'm done. That's my final function after transformation. Okay? Let's write out the description of what happened, which was right here. We already did the hard work. Now we just need to write it as a full sentence. So we can write something like the graph of, I'm sorry, one more time?
It's vertically compressed by half.
Beautiful. Yes, I'm going to write that the graph was vertically compressed. So I'm going to write the graph of this thing because we like to be specific in math. And he said I should write vertically compressed by a factor of 1/2. And so you can see where I'm getting all this information. I'm just going to highlight the pieces that were copied. Question? Feeling really good about this? All right, let's do one more from this top section just to make sure we're feeling good. I think I would like to do the one right above it, but if you feel differently, let me know. Okay. The reason I want to do the one right above it is because it looks identical. I mean, look at this. Right? It's the exact same setup. It's another vertical something. It's a stretch or a compression. It just has a different factor. But look at the f of x function. It has a thing on the outside of it, which is going to make this look slightly different. Okay? So let's handle that, and then we'll come in and we'll pick up what you said about it being a stretch. Okay? So let's do the algebra first, and then we'll do the languagey part. All right, so I'm going to rename this function. Because no one told me what name they want me to give it, I get to make up whatever name I want. So I've named this f prime of x. That little prime symbol meaning I'm changing it. All right, and this says that I need to take 3 and I need to multiply it to my f of x function, which up here was told to me to be that. This is a case where I'm going to distribute, because that -1 is not inside the absolute value. It's hanging out outside, which means I can affect it by that 3. This 3 is going to multiply to the absolute value, not inside of it, but to it. And then it's going to multiply to this -1. So it looks something like this when I'm done with it. Ask me your question. I'm going to zoom out so you can compare it to the one below it. Ask me your question. Do you see why? Okay. She saw it. If you're not sure what she saw, ask the question. She saw that in this one, I was not able to distribute because the +2 was inside the absolute value. But this one's not inside the absolute value. So I was able to distribute to it. Good. All right, going to pick up what Ernest had said earlier. He said that with this we had some sort of vertical stretch. because he noticed that value was bigger than 1. And what is the stretch factor?
3.
Good. All right, so let's go ahead and write our sentence. I'm basically going to copy the one from below, and I'm just going to change the information. The graph of, writing my function thing, was vertically stretched by a factor of 3. The highlight is just showing you where I pulled information. You don't have to highlight, but you can if you want. We all right with this? Good. All right, I'd like to save the other 2 that we have for tomorrow's warm-up and recall, but if you'd like me to do one more of these, I'd be happy to. All right, I do have 2 more at the bottom. I want to do just one for sure. Which one makes you feel like you're going to break out in hives and have a heart attack and freak out? Okay. This one or this one? The one on the left or the one on the right?
Oh, no, the one, no. Or this one, the left.
I think
The other one.
no,
Left.
no,
Do both now.
They're both hard.
They're both hard. Do you want me to just do both?
Yes.
Okay. And so that means I'll make up another one for the warm-up one. Okay, so let's do this one first. If I look at my transformation first, I notice that the transformation is happening inside of the function, which means in my function, the only change is going to happen right at the x. Everything else is going to stay the same. Now the directions tell me to rewrite the new function as g of x, and so I'm forced to choose the name g of x. All right, so g of x equals, and I'm going to write whatever it was that the transformation said in place of x, and everything else is going to be the same. My transformation was x plus 1. Ask me your question about that. Mhm.
Listen, that's supposed to be after the, what's the one that's supposed to be like absolute?
Okay, this is a parentheses, and this is a parentheses, this is absolute, and this is absolute.
Oh.
Okay,
Miss, but how
thank you.
come on the other ones,
Okay, so you just replaced the x with the other.
But how come the parentheses went inside this and the absolutes?
On the outside. Because the only change I'm making is to the x, and this is like more than one thing in there. And so I want to make sure that that gets reflected, and I don't lose anything in case there were multiplications happening. So whenever I replace and make a change, I like putting it in parentheses just so that it shows that whole group is what's getting changed. And then I go, okay, do I really need these parentheses? And I start removing them with whatever techniques I have to remove them. Okay. All right, going to simplify this down because it looks a mess. Inside the absolute value, the 1 and the 3 can play and have a party. And it stays like that because I can't push the 4 into the absolute value, and I can't yank the negative 2 out. So this is my final results. I got asked to do the second example on this, so before I scoot it over, is there a question on this one?
You don't need to
The directions don't say that I need to do a sentence, so no, I don't have to. But if you want to, we can. Do you guys want to see the sentence writing on this one?
Yes.
Yes? I've got a few yeses, okay. So if I look in here, I'm changing this, and it's an add to the input. If I look back at my notes, that looks like this, which means it's a horizontal translation going to the left. Yes. So this is, I can write either horizontal translation or I can write shift, whatever you like. I'm going to write it this time with the translation. This is left 1 unit. And so my sentence then becomes the graph of this was horizontally translated left 1 unit. My blue highlighter is wanting to quit out on me. Note to self, buy more blue. Alright, do you guys still want to see the second one, or do you want to leave this for warm-up tomorrow? Warm-up tomorrow? Alright, sounds great. That's all I had for you today. Thank you very much.